Today we're going to talk about how to install dual Y steppers on the BTT Octopus Pro. Just so you know, the configuration for this is exactly the same for the Octopus version 1.1. So I'm going to walk you through this real quick. So first we have our steppers. So we normally have our X stepper, our Y stepper, our Z stepper. Then we have E0, E1, E2, E3, and E4. But on this particular board, it's going to be slightly different due to they designed the actual firmware to emulate a Voron. So I'm going to show you how to deal with that. So the first thing that we need to do is actually zoom in on this stepper, which is a TMC 2225. And I'm showing you this one. It's very similar to, if not exactly the same as, a TMC 2208. So as you can see, there's the enable pin located right here, and then they give away the color on the side, which is going to be red. And then on the other side, it's going to be black. So you can see right here, the enable pin would be located here on this red row. And then there's another black row to help you align it. So what we're going to do is we're going to go over to the computer for a moment. And we're going to actually look at the manual. So as you can see right here, we have the manual for the BTT website on their GitHub. I'll include the description for where this is located for you so you can find it. But what we're going to do is we're working with the with the BTT Octopus Pro, not version 1.0, but the manuals are very similar. So I'll show you how to find the other one. If you click on repositories, then type Octopus, you'll see the Pro right here. And you can see that you have your hardware for your pins located right in here. Now this is kind of hard to read, but you can see the enable pins right there. It's actually easier to use the other pinout diagram. So we're going to do that in just a second, but we're going to check the manual real quick. So I'm going to go back to the Octopus Pro, show you where the manual is and what we need to set. Now I'm going to have to scroll down for a second to find the actual information, but it's going to be somewhat relevant in this case that we know it. So we're looking for steppers in the manual. And so we're scrolling by a lot of other information, but you can see there's step-dir. We're not using that. We're actually using UART. So it's going to be the next one down, which is located right here. And you can see what the jumper configuration is, where you have the empty pins, and then you have a jumper right here. That is our UART mode. So now that we know that, let's go back and check a couple things in the other configuration so you can see that they're quite similar, except there's more detail, I believe, in this pinout configuration, where you can actually see that it's motor 0, 1, then it's motor 2_1, motor 2_2, which is associated with this stepper. But if you add a second Z-axis, this stepper is going to be occupied in motor 3. And then motor 4 is going to be your first extruder, or extruder 0. And I'll show you this in a moment. And then you're going to have your actual stepper for what you're working with is going to be motor 5. So I'll show you how that works. If we click on VScode, we can actually open our configuration by clicking on this, then open folder. Then we're going to say our downloads folder, then our first Marlin folder, and our second Marlin folder. This is already extracted, by the way, so we'll select the folder. And where I'm actually finding this is actually right here, which is the current version that I'm working with. So this is subject to change. I have no way to control it, and things may change in the firmware in the future. Just keep that in mind. So if we're in here, you can see that first of all, the default environment is for a Mega 2560. This is always going to be that way. at least into the near future, if not forever. And that was the first board it was developed on. So what we need to do to set up our configuration is go to the Marlin folder, then config.h, and set our motherboard, which is going to be right down here. And as you can see, it's currently the ramps. So to do that, we'll click on source, core, boards.h. We'll search on Octopus. And as you can see, we're using the Pro at the moment. So I'm going to copy that. And we're going to use that in a moment, but I need to point out that they're using two different chipsets, which are the MCU, or the big black square in the center of your board. And I'll have writing on it of one of these two things. That's kind of relevant due to it has two chipsets. And the two chipsets can vary because it can be either one or the other. And in this case, the reason that it's occurring is because there's a chip shortage at the moment. So they are substituting in a different chipset if they run out. So we are currently using the STM32F446, which is our configuration for this chipset. So what we're going to do is we're actually going to go and paste in here that which we just copied. And we're going to change the serial port to -1. So that's how you set it up for your USB connection. Next, we're going to search on the A4988. And as you can see, currently our Y stepper is set for just the A4988. In order to use this, it's similar to TMC2208. So we're going to copy that and we're going to paste it right here. Now to use the second Y stepper, we actually have to find it, which is located right here. So we're going to use the control and / to remove the comment. And then we're going to paste our configuration in here. So just so you know, if you're having trouble with your steppers where they're moving the wrong direction, there is a search that you can do called invert. And down in here, you can see that you can change the direction right here for your particular configuration. Now we're running two steppers, so it's going to be slightly different. So let me go back up to our regular configuration up here. And the easiest way to get to it is search on A4988. And we're going to have to worry about this in a moment. And I'll show you why. So currently, if we go to the advanced configuration and we search on 800, you'll see, once we get to it, that the first Y is enabled and it's in a light color, but the second one is not. So we're going to have to go to the top of the file and we're going to have to search on dual. And as you can see, there's dual end stops in here as well. I don't recommend using that. The only reason you would need that would be maybe if you have two different axes running at the same time. This is one axis with two steppers. So we're going to find our Y axis right here, and we're going to do the control / again to remove the comment. Then we're going to scroll back up to the top and search on 800 again. And you'll see what the change is. So right here, you can see now that they're both enabled. Now, this controls the actual stepping in this case, and it's software controlled. And as you can see, this variable is tied to this one so that they work together. Now, if we want to increase the resolution, here's our Y stepper currently, which is 80 steps. If we were to double this value right here to 32, then we would have to double this value to 160. If we double this value again to say maybe 64, then we have to double this value to 320. So that can go all the way up to 256, but that's the process if you want to increase your resolution. Now 256 I don't recommend, even 128 is too much, but that's how it works. So what we need to do now is actually enable the TMC debug. So we're going to search on TMC underscore debug, and we're going to enable this for the moment. You can disable this after you've configured it. So I have to find the other one real quick. So I'm going to do TMC underscore debug, and that'll bring us to the second one, and we'll enable this as well. And this will make sense in a moment because we're using the M122 as a G code to figure out if the steppers are okay. Now, we may get an error, and I'll show you how to troubleshoot that in a second, but the easiest way to understand what's occurring in this case is we're going to have to go over to the source folder in a moment, then go over to the core folder, and then we're going to have to, not core folder, we're going to have to go over to the source folder, then we'll go over to the pins folder, and inside here we'll find our chipset, which is STM32, and I'll point this out in a second, but there's one quick thing I want to show you about power. If we search over here on 12 volts, there is a setting that you may or may not use that involves controlling your chopper default. You can set this for your power supply, which is in most cases going to be 24 volts. I personally don't use this functionality, but there's other interesting things in here about higher degree step steppers. We're currently using 1.8 degree step. This is twice the resolution right here, but I've never actually used or tested this functionality. So now that we understand that, let's go back over to the actual boards for the pins. And I want to show you this because it's very important in this case, because it's based on the Voron configuration for a printer. So if we search through here, we can find our board, which is going to be the Octopus Pro. So you can see it right here. And we don't see a lot in here. And the reason for that is that there's an include, which appends the information from this file into this file. And so this setting may change in the other file. And the reason that they do that is if they make a small change, they want to actually add it here and then append it to here. So this will override whatever value is in here. So if we go to the Octopus Common, you can see all the pins. Now this is kind of important, and the reason I'm showing you this is to resolve an issue that you may come across. So as you can see, we have our X stepper right here, then we have our Y stepper, then we have our first Z stepper, then we have our second Z stepper, then we have E0. So the actual stepper motor that we're looking for is motor 5 to be our second Y stepper, because these two right here are changing the normal order of things that we would work with. If this one didn't exist, then it would default to up 1 in other boards. So now that we know that, we're going to have to go over to the board and configure this. So I'm going to take you back over to my desk for a moment so you can see what I'm talking about. So we have our X stepper right here. Then we have our Y stepper, our Z stepper, then our second Z stepper, then E0, then E1. So I'm going to pop out these steppers right here for the caps. And the reason I want to do that is so I can set the jumper correctly from the manual. So once they're all out, we're going to place the jumper in the position that we need to be in, which in this case is going to be right here. So now I'm going to insert this. As you can see, there's red on one side, black on the other. That gives away how to do it. The enable pin's in the top part right here. So we're going to align that right here and place it in here. Now, as you can see, I have cooling fins on this one, which you normally would have on both. And you'd run with a cooling fan to keep these nice and cool. That is located in my playlist, which I'll link to, where I talk about cooling fans, and it's in another stepper tutorial. So I have to do the same configuration for the first Y, which is going to be X, and then Y. So we'll pop these out real quick. And once these are out, we'll set up the configuration. So the whole description that I was giving you about the second Z offsets everything. So that now is in place, hopefully in the right place. Looks like it from here. So what I'm going to do is I'm actually going to place the stepper above it right here. And we're all set. And once again, you want cooling fins on both, and you want cooling. Now I'm also going to set up the actual configuration for the actual power. So in here you can see that this is the stepper power, and I have a red wire and a black wire. Red wire is voltage, black wire is ground. It's running to the power supply. And then I marked red on here so that you don't accidentally plug in things backwards. So I'm going to place this in here, tighten it down. I'm going to do the same thing over here and tighten it down. Now I'm going to do that for the power on the board as well. So I'm going to place this in here. Make sure it's nice and tight. And then do this. Then I'm going to close this for safety. Next, what I'm going to do is I'm going to remove the drive right here and place it inside of here. And then place this in the computer, so you may hear a beep. And just so you know, when you're running TMC steppers, in an actual configuration, you're going to remove the jumper for the USB power, but we're going to use it to load firmware. And as you can see, it powers right now, but I'll show you in a moment. We'll pop that off and do something different. But let's go back over to the computer for a moment. And on the computer, we need to set up our build. So I'm going to minimize this for a second, then minimize the pins file and the source file. And we're going to have to set the platformio.ini for the default environment. In this case, it's the Mega 2560, which is not our default environment. So we're going to go over to the INI folder. We're going to find our chipset, which is STM32F4. And inside here, we're going to search on Octopus. And as you can see, there's several configurations for Octopus. Up here, we have it for both version 1.1 and Pro, but there's also the other chipset, which would be the STM32F429, which is located down here. And I don't advise using USB because this causes confusion at the moment. So we'll get to that some other time. So I'm going to copy this default environment right here. And I'm going to close out of the INI, then I'm going to go to the platformio.ini, and I'm going to paste our environment right here. Now, before I actually build, I need to show you that they build before they release, and then they have the Mega 2560 in here. We're going to take it out with a little garbage can down here, which is clean. So that's no longer there. So we'll now click on the checkbox, and this will do our build. Now, just so you know, if it fails on the first build, hit the checkbox a second time, because sometimes things build out of order. So in this case, you've seen it happen. So I'm going to click it again, and hopefully this will take care of the situation for us. If it doesn't, we'll have to correct the first thing that fails in the list, and it'll be in red. Anything else after that may be a cascade of errors due to the first error. So this is almost built. As you can see, it's building in here and populating this folder. And in a moment, we'll see our actual firmware.bin. So let's give this a second to actually finish. And as you can see, we're almost there. This usually gives away that we're there. So there's our firmware.bin. So I'm going to right click on that and I'm going to say reveal in File Explorer. So this is our current firmware build. So if we click over here, you can see that we have a firmware.cur on our drive. This was the last successful load. So I'm going to go back over here and right click and then paste this into there by doing send to. So as you can see now, it's here. If you wanted to load the firmware.cur on another configuration, you would rename it to firmware.bin. So what we're going to do next is go over to the desktop and actually install this. So on my desk, let me get that up so I can see it. I'm going to pop out the drive. I'm going to place the drive in here. Now, as you can see, we've got several things we have to plug in still. So I'm going to plug in the first stepper right here. And then the next one, we get to count outwards. So we have X, then we have Y, Z1, Z2, E0. So it's going to be, let's see, that's Z1, Z2, E0. But in this case, it's going to be Z2 because of the way the pins are set, then E0, then right here. So now that we have both of those configured, what we can do is we can actually plug this in and load the firmware. Now you can see there's a blinking light. There's going to be a beep on the computer if it's successful, which we just heard. So we're going to remove this for a moment. Let this just charge for a second, make sure no lights are on. Then remove this jumper because this will interfere with the actual TMC by resetting them if it's there. And we'll plug this back in. Now there's no power currently because it's unplugged, so I'm going to plug this in. And then I'm going to go over to Pronterface in a second so that we actually can see the configuration. So I'm going to transfer over to here. And as you can see, it says COM port 1. If we click on COM port 1 to connect, it will fail because this is a default for the computer. But sometimes it'll show up in here as COM port 15. But the way to check this is to actually go over to your desktop for a second. Then you'll type Device Manager. And Device Manager will appear on your screen where you can click on the ports and see that it's COM port 15. So I'm going to close out of there. I'm going to click the drop down for this so that we can select it. And then I'm going to say connect. So now the printer is now online. To check the actual steppers, we're going to type M122 and press enter. And as you can see, I've got a bad response on the second actual stepper. So we're going to have to troubleshoot that real quick. And we have to make sure that we're connected to the right stepper. So we're going to go back over to the workbench for a second and see what we got. So I'm going to unplug the system, let it discharge for a moment. And we know that the issue is going to be under Y2. So we're going to count these out again just to make sure we're in the right place. So we have X, Y, Z1, Z2, E0, then we have E1. And you can't see what the actual issue is, but I plugged it in incorrectly right here. So it's not fully plugged in, so I have to pop this out and align the pins correctly. Hopefully I've not damaged my board, but apparently these are a little tough to work with. So there it is. So I'll plug that in, and I'll plug this back in, hopefully in the right place, but we'll count it out one more time. So we have Z1, Z2, then we have our second Z, then we have E0, E1. So we know we're in the right place. Let's make sure that's down nice and tight, as well as that, and we'll plug this back in. So let's go back over to Pronterface for a moment and see what we get. So we're back over to Pronterface. We're going to have to do a disconnect, reconnect. Then the M122 again. And as you can see now, it's functioning correctly. So what we're going to do is we're going to try and move the Y axis. So I'm going to go over and move it 10 and see what happens. So it works. Let's try and move it back. So as you can see, that's how you set up dual Z stepping. At this moment, I want to thank my patrons for helping to make this possible, and also the people on PayPal. I'll include a thank you note at the end of this tutorial. So everyone, be safe, get vaccinated, wear a mask, and take care.